Hi there, in this video we're looking at factorising quadratics where the leading coefficient a is greater than 1. I'm going to show you a slightly different method to the ones you might have seen before. Some have us splitting this x term, which leads to having to factorise linearly a few times. This method's a little bit more straightforward than that. Some methods have us trial and erroring, which again isn't very direct, and this method is a little bit more direct and leaves a little bit less to you spotting the right thing. So I'll run through the method and then we'll have a look at why it works and some special cases where we need to be a little bit careful. So let's go through the method. So first step is we do 5 times by 8, or the a times by c, which gives me 40. And then just like factorising where a is equal to 1, we're looking for a factor pair of 40, which adds to give me negative 14. In this case, it's quite easy to spot that it's negative 10 and negative 4. So then again, just like normal factorisations, we draw our two brackets and we're going to put negative 10 and negative 4 in our brackets. Normally we'd put x here, but we've not just got x squared, we've got 5x squared. So we're going to put 5 there and there. So I'm sure some of you are scratching your heads thinking, but this bracket doesn't equal this, and that's absolutely correct. If we expand that out, it's going to be 5 times too big, so we put a fifth there. And generally with this method, it's going to be whatever your coefficient of x squared is, that's what goes on the bottom of your fraction. So now we need to simplify or reduce these brackets. So highest common factor of 5 and 10 is 5, so I'm going to times by a fifth. Highest common factor of 5 and 4 is 1, they're co-prime, so I can leave that bracket the same. But what this allows us to do is it means that if we times this bracket by a fifth, we're using this fraction at the front. So we're going to combine this fraction at the front with this bracket to give me, 1x minus 2 and 5x minus 4. And if you expand that out, you can check, you'll get this correct answer. Okay, so the previous example wouldn't have been too difficult to trial and error. We only had a prime number at the front here, so there are only two different avenues to check. Here it's a little bit more tricky. Both of these numbers are composite, which means it's going to give us, again, more and more combinations to check as these numbers get more complicated. But we'll run through this method and you'll see that it's exactly the same. So 12 times negative 10 is negative 120, and we're looking for a factor pair of negative 120 that adds to give 7. Now if we're unsure about this, we can just start listing factor pairs. So 1 and 120 is clearly way out, 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 60, 6 does go into it, 6 goes into it 20 times, nearly there, 8 and 15, and then we can stop because plus 15 and negative 8 give me 7. So same method as before, the 12 is a 12th, 12x minus the 8, 12x plus the 15. So highest common factor of 12 and 8 is 4. So we're going to times by a quarter. Highest common factor of 12 and 15 is 3. So we're going to times by a third. Again, a quarter times a third is 12, a 12th. So we're splitting this fraction and incorporating it into the two brackets as we reduce them down. So a 12th times by a quarter, or 12 times by a quarter is 3x minus 2, then times the second bracket by a third, 4x plus 5. And we're done. Okay, so in this example, you might have noticed that 12, 14 and 10 all share a common factor. So what we could do is we could pull out a factor of 2 straight away and factorise linearly first, and then factorise the resulting quadratic. Sometimes if the numbers, the common factor is a bit more difficult to spot than 2 though, we might not realise to do that. But this method will still work. And there's a little extra consideration, but we can still use these method even if we forget to pull out a linear factor at the start. So we're going to do the same method. 12 times negative 10 is negative 120. We're looking for a pair of factors of negative 120 that give me negative 14. So again, 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, nearly, 6 and 20, there we go, and if we've got negative 20 and 6, that gives me negative 14. So 1 over 12, 12x plus the 6, 12x minus the 20. So highest common factor of 12 and 6 is 6, so I want to times that by a sixth. Highest common factor of 12 and 20 is 4, so I want to times that by a quarter. Now this isn't going to incorporate the 12th correctly at this point, because you might have spot 1 over 6 times 1 over 4 is 1 over 24, not 1 over 12. But that's not too difficult to fix. Instead of 1 over 12, we just need to say that's 2 over 24. So then the sixth and the quarter incorporate the 24, and we are left with 2 lots of 2x plus 1, 3x minus 5. And because the 2 is left over from the 2 over 24 that we had to do to make the 6 and the quarter, and cancel with it. And we're done. Okay, so the last question to answer is why on earth does this work? So what we'll do is we'll sort of produce ourselves a quadratic completely generally. So ax plus c and bx plus d. If we expand that out, we get abx squared plus cbx plus adx plus cd. If we factorise this to get x on its own, cb plus adx, abx squared and cd. Okay, actually let's do the x's in a slightly different colour. There we go. So we've got abx squared, cb plus adx, and then cd. So that's going to be what we're starting with, and we're just going to follow our method through with this. Okay, remember our first step was to multiply the coefficient of x squared by cd. I'll do that just underneath. And that's going to give me ABCD. And we're looking for a factor pair of ABCD, which adds to give me CB plus AD. Well, so if we do CB times AD, then that's going to give me ABCD. So we should hopefully see that a factor pair of this number, if we started with something that was factorised, is always going to give me something that adds to give me this coefficient, which is nice. So then what was our next step? So we divided by the coefficient of x squared, so we've got 1 over AB, and then we wrote ABX plus our first term, AD, and then we wrote ABX plus our second number, CB. And what you should see is the highest common factor here is A, so we're going to times by 1 over A, which is this A. Our highest common factor here is B, so we're going to times by 1 over B, which is our second number there, which falls out, well, ABX divided by the A gives me BX, and then we get rid of the A to leave D, and then here we get rid of the B's, and that's AX plus C, which is exactly what we started with which means that this method, provided it can be factorised, should always give us the thing it factorises to. Okay,